No need to navigate to any other. Computer A broadcast. If A broadcast, D and G will receive everything, right? If A broadcast, A belongs to the green VLAN. Whatever device in the green VLAN will receive everything. A broadcast, then D and G receive. Right. So except the first one, other two examples are understandable. I think first one, some confusion is there. Definitely, there is no possibility to communicate in between the VLAN. If the router involvement is not there. If the router involvement is not there, it is not possible to do the communication in between the VLAN. Router involvement is there, then this situation is possible, but in between the router should involve. Switch A, after that router should involve. Then back to switch A and switch B, like that, and things will be processed. So I think better forget about the confusion with the example 1 and understand the example 2 and 3. Then benefits of the VLANs. The key benefits of the VLAN is that they permit the network administrator to organize the LAN logically instead of physically. So that is the much benefit. Physical LANs are obsolete now. Use the VLANs. This means that administrator is able to do all of the following: easy move workstation on the LAN, easily add workstation to the LAN, move, change the VLAN configuration, we change the LAN configuration, control network traffic, improve security. So we keep discussing on those at different points. VLAN types. There are 3 types of VLAN: port based, MAC address based, which is the one we already discussed. Then protocol based, we have not yet discussed. Based on the protocol also, we can do some sort of a administration to the VLAN, right? Establishing VLAN membership. Approaches can vary. Approaches can vary the performance. Different. These 3 approaches are there for 3 different purposes. මේ තුනම මොකක් හරි advantage හරි disadvantage හරි තියෙනවා. ඒක අපිට මෙහෙම තුනක් ඕනේ වෙලා තියෙන. නැත්නම් එකකින් වැඩ විසඳෙනවා නම් ඒක විතරක් popular වෙනවා, but not the case. There are different situations that we have to adapt one of these, right? So typical environment, port based is the very common approach, but MAC address based and protocol based approaches are also there. Membership by port, user assigned by port association, require no lookup if done ASICs. Better looked into the what it stands for. Easily administrated by via GUIs, maximize security, packet don't leak into other domain, easy to control across the network, right? So these ports related different labels are there. VLAN 3 related ports, VLAN 1 related port, VLAN 2 related. For each VLAN, we can introduce the link to the router, but it is not so common because we can even share that link logically to communicate on behalf of the multiple VLAN. Otherwise, when we introduce the multiple VLANs, maybe 3, 4, 5 VLANs, at every time we have to introduce the link to the router. So port with the router might be limited. So we better share the link for multiple VLANs, then things will be shortened out. Right? First case, it is all about sharing the medium. So it doesn't say doesn't label Okay, so using layer 3 routers to link the VLAN provides the following benefits. You better go through that, right? Protocol base is the configure like MAC address, but instead use a logical or IP address, no longer common because of the DHCP. So protocol base one is no longer common because of the DHCP. Because we cannot, the IP addresses are not predefined. If predefined IP addresses are there, then based on the IP address, we can introduce the different VLAN. That is the idea. But it is now obsolete as per then. So you are familiar with the port based and MAC address based VLAN. So we move forward with that understand. Frame headers are encapsulated or modified, right? Frame header. Frame header mean layer 2 related data unit is the frame. Header mean its header, frame header. Are encapsulated or modified to reflect the VLAN ID. What is going to incorporate with the frame header? It is the VLAN ID. Before the frame is sent over the link between the switches. Before sending, we have to put that VLAN ID. එක තමයි cap එක. එතන cap එක දානවා කියන එක එතන චුට්ටක් එහාට කියප එක. VLAN ID එක කියන්නේ VLAN number 10ද 20ද කියන එක. ඔව් ඒ cap එක තමයි ඒක. VLAN 1020 එක දාලා හැබැයි ඔක එළියට යද්දි encapsulate කරන්නත් ඕනේ trunking එක through යද්දි VLAN ID එක පෙන්න තියෙන encapsulate කරන්නත් ඕනේ ඔක්කොමලා treat කරන්නේ එකම විදිහට. VLAN එක base කරලා trunking වලදී prioritize කිරිල්ලක් කෙරෙන්නේ නැහැ. Right? Before forwarding to the destination device, the frame header is changed back to the original format. Make a VLAN එක ඇතුළට ඇද්දි before forwarding to the destination device, that means within the VLAN, no need to use the tag. Like remove the cap once you get into the house. House එක ඇතුළට ඇද්දි cap එක ඕනේ. House එකෙන් එළියට ඉතින් මම මේ house එකේ කියන්නේ ඔයාලට cap එක ඕනේ. So IEEE 802.1q is the VLAN tagging mechanism. Tag protocol ID, user priority, canonical format indicator, VLAN ID. Those are the information with that 4 bytes, which are with specific information. No need to deal with thoroughly with those information, but you should have some understand how that tagging mechanism happen. IEEE 802.1q is the standard. So you should have that understand. Right, so the number of VLAN in a switch vary depending on the several factors: traffic patterns, type of the application, network management needs, and group commonality. Group commonality. So, are you agree with me? Based on these different purpose of the use of the different use of the network, those devices are grouped. In addition, an important consideration in defining the size of the switch and the number of VLANs is the IP address scheme. In addition to important consideration defining the size of the switch and the number of VLANs, IP addressing scheme. Right, IP addressing scheme is also important. For example, network using 24-bit mask defining the subnet of 254 host allowed one subnet. Give this criterion total 254 host addresses are allowed on subnet. So actually, when you introduce the VLAN, you should be careful how to assign the different IP ranges for the different VLAN. It is always focus how many number of devices in the network, at the same time how many VLANs will be there, because usually from the network part we take couple of bits to define our VLAN as well. So that thing for VLAN IP assignment we should do very carefully, because one-to-one correspondence between the VLAN and IP subnet is strongly recommended. There can be no more than 254 devices in any VLAN. It is further recommended that VLAN should not extend outside of layer 2 domain of distribution switch. It is obviously happened, right? It is further recommended VLANs should not extend outside the VLAN to layer 2 domain of the distribution switch. So is there any situation where it extend over layer 2 domain? As far as my knowledge, I always it limit with the layer 2. Actually, VLAN capable switches always support for layer 3 communication, but functionality wise, operational wise, no much involvement with the layer 3. Right? So basic IP assignments and things are there, right? VLAN capable switch. Based on that, actually, VLANs are introduced. Other than that, no much involved. Right. Inter-switch link. There are two major methods of frame tagging. That means Cisco introduced something, but it was not popular. Two major methods, frame tagging, inter-switch link, ISL, and 802.1q. ISL used to be the most common, but is now being replaced with the 802.1q frame tagging. Right? Inter-switch link, fast Ethernet, ISL header encapsulate the LAN frames there in the VLAN ID field in ISL header. Frame is length. 802.1q, fast Ethernet and FTDI. Right? Anyway, the description is there. I want to emphasize that IEEE 802.1q is the popular one at present. ISL, as I can remember, it is introduced by Cisco or one particular vendor. It was common during a particular period, but after some time, as it is very unique to the Cisco, other vendors didn't follow with interest. The international body introduced some other platform, 802.1q, which is the common and popular platform for tagging. Tagging කියන්නේ cap එක හදන්න 802.1q තමයි follow කරන්නේ. So VLAN type, Cisco Catalyst switch historically have supported only up to 1024 VLANs due to the use of 10 bits as the VLAN ID. VLAN ID. Always may bit කීයක් තියෙනවද කියලා තමයි අපි හිතන්නේ. ඒක අනුව තමයි maximum number එක. දැන් port number එකේ port එක 65536 වෙනකන් යන්න පුළුවන්. 5 වෙනකන්. ඇයි bit 16ක් තියෙන නිසා. IP එකේ 8 blocks තියෙන හින්දා එකක් 256 වෙනකන් යන්න පුළුවන්. මෙතෙන්දි 10 bit තියෙන හින්දා VLAN ID can be extended up to 1024. Trunking provides the ability for a single layer 2 port to transport the traffic from multiple VLANs rather than from just a single VLAN. Trunking provides the ability for single layer 2 ports to transport the traffic for multiple VLANs rather than for just single VLAN. Yeah, that means yeah, it is about the trunk. Trunk means the shared transmission media. It always provides the multiple VLANs to share the traffic. That is the understand with that point. Right? Trunking. We will get into the trunking part in detail later in the slides. To support this functionality, a tag is required. And trunking වලට tag එකක් ඕන. cap එක ඕන. tag is required that identify the VLAN ID frame is associated with. house එකේ නමට පාට පාට tag cap තියෙනවා වගේ VLAN ID එක පාවිච්චි කරනවා tag එක විදියට. tag එකේ part එකක් විදියට එතකොට වෙනම අඳුර ගන්න පුළුවන්. later version of the ISL use the 15-bit VLAN ID මේ ISL ගැන කතා කරන්නේ. And standard based on the IEEE 1Q trunking protocol 12-bit VLAN ID which provide for up to 4096 VLAN. Doesn't matter, those are not for your information, it is important. ISL was used before 802 1Q protocol support was present. Hence, a large number of catalyst switches supported only 1024 VLAN. That means Cisco. ISL is the Cisco version. Catalyst switch maintain VLAN database, which is listing all VLANs associated parameters such as VLAN ID and name, and a list of each port associated with each VLAN. And list of each port associated with each VLAN. So whatever the information with related to the VLAN, specific informations are used to separately identify the VLAN anyway. LAN emulation is a way to make an asynchronous transfer mode network simulate an Ethernet network. LAN emulation is a way to make an asynchronous transfer mode network simulate an Ethernet network. Ethernet environment එකේ ATM implement කරන්නේ LAN emulation කියලා. That is the idea that ATM approach we have never touched, but it is the industrial form of a network. So that thing is there in the Ethernet platform as a LAN. There is no tagging in the LAN, but virtual connection used to imply the VLAN ID. VLAN tagging එකක් නැහැ, නමුත් VLAN ID එක use කරනවා. As the packets are received by the switch from any attached end station device, a unique packet identifier is added with the each header. Unique packet identifier is added with the each header. I would repeat that. As packets are received by the switch from any attached end station device, a unique packet identifier is added with each header. Okay, then it says header is manipulated accordingly. Once it's received from the or based on the inbound traffic, just looked into the end station related or source and related information and manipulated accordingly before moving forward, right? So it is about the LAN emulation replacing the functionality of the ATM in the obsolete network. This header information designated with the VLAN membership of each packet. Packet is then forwarded to the appropriate switches or routers based on the VLAN identifier and the MAC address. Right? So packet is then first point is this header information designated the VLAN membership of the each packet. VLAN membership එකක් විදිහට ඒ කියන්නේ tagging mechanism එක වගේම තමයි, but LAN emulation වලදී ඒක approach එක වෙනස්, ID එක විතරයි ගන්නවා කිව්වේ. So second point, the packet is then forwarded to the appropriate switches or routers based on the VLAN identifier and the MAC address. VLAN ID එකයි MAC address එකයි use කරලා තමයි ඊතර communication ටික කරන්නේ. So we are talking about that LAN emulation approach. Upon reaching the destination node, the VLAN ID is removed from the packet by the adjacent switch and forwarded to the attached device. Packet tagging provides a mechanism for controlling the flow of broadcast and applications while not interfering with the network and applications. Tagging provides the mechanism for controlling the flow of broadcast. Okay, tagging use करना और broadcast control करना and application while not interfering with the network and application. Anyway, the general purpose of use of the tagging, once you use the hat or cap during the house meet, sports meet in the school, then some sort of a understanding is there with everyone. This bugger is belongs to this house, like that. So same nature is there with the tagging over the network, which provides the implicit understanding about the uh, relevancy or belongingness of the particular traffic. කාටද අයිති වෙන්නේ කියන එක දැනගන්න. Then VLAN configuration. Okay. Any question, little? I'm just moving forward today because once I see the number of slides for this section, just moving forward little fast. Any question? Even you can raise at any time. Just drop me a WhatsApp if you have not understand anything. I will get back to you after that, right? As far as we covered the lab 1, which is related to the VLAN, lab 1 or 2, which is related to the VLAN, I think you have some understand about the VLAN, and these sessions will help you to thorough with that understand. Okay, so in a switch environment, a station will see only traffic destined for it. Switched environment, you can VLAN 10 වලට පේන්නේ VLAN 10 traffic එක විතරයි. So you can understand that part. Switch filter the traffic in the network, allowing workstation to have full dedicated bandwidth for sending and receiving traffic. Yeah, dedicated bandwidth. They can bandwidth එක B නම් LAN 3ක් VLAN 3ක් තියෙනවා නම් B බෙදීම 3 B බෙදීම 3 B බෙදීම 3 කියලා තුනට වෙන් කරලා දුන්නොත් නැත්නම් B බෙදීම 6 එකක් 6න් එකක් එකට දෙනවා අනිත් දෙකට දෙනවා 4න් 4ක් ඒ කියන්නේ 3න් 2ක් මොකක් හරි කම්බිනේෂන් එකක්. ඒකම බෙදලා දුන්නාම VLAN වලට වෙන වෙනම bandwidth එක they can utilize it within their network. No need to worry about sharing with someone else to avoid the unnecessary interruptions. Unlike a shared hub system where only one station can transmit at a time, the switch network allows many concurrent transmission within the broadcast domain. Right? It is about the introduction of the collision domain. Hub එකේ collision domain එකයි තියෙන්නේ, switch එකේ multiple collision domain තියෙනවා. So it is possible to conduct the multiple communication at the same time. Switch network does this without directly affecting other station inside or outside the broadcast domain. So that is the again emphasizing the features with the broadcast domain. Collision domain. So it is about the concurrent transmission. No need to go through that. The station pairs A, B, C, D, and E, F can all communicate without affecting other station pairs. Each VLAN must have unique layer 3 network address assigned. This enables routers to switch packets between the VLAN. So I think make A, B, C, D, E, F වෙන වෙනම VLAN තුනක තියෙනවා කියන්නේ. එතකොට මේ traffic එක කාටවත් disturb වෙන්නේ නැතුව they can communicate to each other. That is the arrangement here discussed. 100, right? 100 slides. 101. So VLAN can exist either as end-to-end networks. VLAN can exist either as end-to-end networks or they can exist inside the geographical boundaries. End-to-end networking complete connectivity is there. They can exist inside a geographical. I think it is something within the building or something inside the. Even extending it also possible. Even university also we have two buildings, and so we cannot say specifically they can exist inside of geographic boundaries. I think they wanted to emphasize the point that if we are going to introduce the LAN without having that virtual concept, then we can link multiple routers and introduce that backbone network. That VLAN there is linking with the router. එතකොට router එකට connect වෙනවා නම් අපි මේ university එකේ router කිව්වොත් KDU එකේ router කිව්වොත් ඒ router එකේ interface එකකින් VLAN කතන්දර ඉවර වෙනවා. It is not further extending. Wide area network කතාවට යද්දි VLAN කියලා දෙයක් නැහැ. මේ university එක දැන් අපේ University of Vocational Technology University colleges එක connect කරනවා කියලා හිතන්න. So VLAN කතාව තියෙන individual university එක ඇතුලේ විතරයි. Connectivity from this university to university colleges through the public network is some other form, not use the VLAN concept. So that is the idea. That means VLAN concept cannot be extended, right, over the public network. VLAN concept cannot be extended over the public network. It is introduced through the router interface only. Then it will not be extended for large set of buildings or geographical areas. So into a network, it's okay. That means whatever the reliable communication is achieved through network, obviously. So with the end-to-end VLAN networks comprises the following characteristic. Users are grouped into the VLAN independent of the physical location, but dependent on the group or job functionality. So you have that idea. If you have any question, you can raise, but that point we already discussed. All users in the VLAN should have the same 80-20 traffic flow patterns. What is that 80-20? All users in the VLAN should have the same 80-20 traffic flow pattern. Can එයාලා generate කරන traffic එක, or they are generating 20% of the traffic, they are accepting 80% of the traffic, something like that, right? 80-20-80 or 80-20 rule is very common. So that is all about their contribution towards the network. All users in the VLAN should have same 80-20 traffic flow pattern. So they just generate 20% of the traffic, they just accept the 80% of the traffic, altogether 100. So that is the idea. Then moving forward with third point, as a user moves around the campus, VLAN membership for that user should not change. It is obvious. I mentioned about the cashier. Cashier can be in the third floor of the or top floor of the new building, ground floor of the new building, or all building. But the VLAN, they should be connected with the finance VLAN. Each VLAN has a common set of security requirements for all members. Each VLAN has a common set of security requirements for all members. It is very common, right? There should not be any multiple way of introducing the security. Yeah, this diagram introduces you what is the difference between the access layer, distribution layer, and core layer. So once you are taking network expertise, then actually if you have contacts with the dialogue, just communicate with them and ask. There are separate engineers. I'm an access network engineer. I'm in the distribution network engineer. I'm a core network engineer. Likewise, the telecommunication service provider related organizations assign the experts into the different level of the network. Then they can closely look into the matter and come up with the solution instead of expert in multiple areas. right? So somehow end-to-end connectivity is facilitated, end-to-end communication is facilitated, source to destination. Part of them, this part is access part is the VLAN, the other part is not the VLAN, right? Red, maybe light blue, black, those are used to represent the VLAN. The other parts are not representing VLAN. Each color represents the subnet. Because people have moved around over the time, each switch eventually become member of all VLAN. Frame tagging is used to carry the multiple VLAN information between the access layer, wiring closets, and the distribution layer switches. Yeah. After that, I would say here the whatever the VLAN related communication happen, but after this tagging is applied. Tagging is applied to treat all the traffic equally. Later on, those will be untagged once return the traffic or return responses are received. Uh, Tags are removed for identifying the original VLAN. Here it says ISL is a Cisco proprietary protocol that maintains the VLAN information as traffic flow between the switch and routers. That is the problem. Individuals can introduce the standard, but those will not be sustainable solution. So always, I never recommend to use the vendor specific approaches because those things will be obsolete at some point. So better you go with the common standard like IEEE, those who are expert in the introducing the standard, and everyone is willing to follow the so such organization instead of following the vendor. Vendor කෙනෙක් බලාගෙන product එකක් හදනවට වැඩිය තව vendor කෙනෙක් එයාලා කැමති international body එකක් follow කරලා වැඩේ කරගෙන යන්න. එතකොට that thing eventually will be popular, so don't rely on the vendor specific protocol. Yeah. ISL some version is not support for trunking in some cases. It is not relevant because we are not going to use ISL even in the labs. Workgroups server operate in a client-server model. For this reason, attempts have been made to keep user in the same VLAN as their server to maximize the performance of the layer 2 switching and keep traffic localized. Hope you can understand that part. Eventually, we are dividing large physical network into smaller part to achieve that manipulating with the traffic. A co-layer router is being used to route between the subnets. The network is engaging based on the traffic flow pattern. 80% of the traffic concerned with the VLAN. 80% of the traffic concerned with the VLAN. 20% of the person crosses the router to the enterprise servers and the internet and WAN. Okay. 80% of the here the focus is 80% of the traffic contained within the VLAN. Whatever the communication, if we have the VLAN 10, 80% of its traffic with related to the VLAN, within the VLAN, two computers within the VLAN are communicating each other. 20% of the communication are moving forward, maybe accessing the server outside, right? 20% go outside to access the enterprise servers. So previously I just mentioned inbound and outbound traffic. Here with this one, all users in the VLAN should have same 80-20 traffic flow pattern. So this is also more relevant if we interpret it as a within the VLAN 80% and 24 outside. as described in the next that slide here. 80% within the VLAN, 20% outside the VLAN. The same thing should be. We will finish at this point. Now it is 9:40. Do you have any question?
No, sir.
Yeah. Right. Okay.